There we go. Yeah, so we finished off with looking at methods. But the methods look a lot like functions, but they're a little bit different. They kind of do the same thing, like it's a chunk of code that will get run to do something, except with the methods, unlike the functions, where the functions you just call the function, and then you give it the parameters it may or may not need, and it does its thing. Where when you call a method, the method is kind of attached to a specific thing, right? Remember we did that example in the last class where everyone was a string, and I said, so-and-so, it's you, what was your name again? Riley dot capitalize, and you're all strings, but who's getting capitalized? Riley. No one else is. So methods are very, very, very similar to functions, but different. At this stage, okay, be honest. Raise your hand if you're like, I don't like this. Just stick with methods, or stick with functions. Methods is this new thing. It's a wrench thrown into it. You're thinking that. Yeah, okay. And you're normal. The reality is at this point, by the end of the course, you're going to be very familiar with the difference. Knowing if you want to do something, oh, is that a function or a method? Do like I do and just go, I want to do this in Python, and then just do what it tells me to do. And then I'll notice by the syntax if it's a method or a function. You'll get used to that. At this stage, it might seem like, uh-oh, this whole new weird idea is ruining everything. By the end of the semester, you're going to be really comfortable with it. And by the end of the semester, we're going to be making our own methods and our own objects. That'll become second nature. At this point, don't panic. We're barely going to be talking about methods for the next couple of weeks anyways. I'm just showing you that they exist. Some of them are pretty cool and handy. Anyways. All right. So we finished up talking about strings. And strings are... Is the audio? Yes. Strings were interesting in that, unlike an integer, unlike a Boolean, like a float or a character, classically speaking, we know, regardless of what number it is, we have an idea, we know how much room it needs to take up in our computer. But with strings, we're in trouble, because we know how much an individual character needs, but we don't know how much a string will need. And we saw that example where if I said some variable equals 5 and I hit run, Python can just go 5. Great, I know I can store that in my RAM, so I'll just go do that. It sits 5 sits in one of the seats. But I also did that example where I did an input, where Python didn't know what the value was. But it did know that, okay, it's going to be like an integer, so I can still have a sense of how much room it's going to take. Not have a sense, I'm going to know how much room it's going to take. So I don't care what value it is, you can all sit in there. If you're all integers, you're sitting in a seat. You can change the seats, it doesn't matter, you all fit just nicely in that chunk. But when strings come up, we're in trouble, because if I'm reading input, I have no idea how big that string is. If I strung along a bunch of you together, such that you were in this contiguous linear fashion, and tried to shove you all in one seat, I'm in trouble. I need multiple seats. And how many seats I need kind of depends on, well, how long is the string? How many of you are there in that collection of you? So strings were different. And strings, you know, they have a beginning, they have an end. And we can index a string to get individual characters, right? We were able to say hello and then say, okay, give me my string at index 0, and it would give me back the H. Now we're going to talk about lists. And we've all been using lists already for a while. You've been using lists for all the labs, if you've done any CATA stuff. You use lists whether you like it or not in assignment 1. If you've started playing with assignment 2, you've been using lists. Lists are probably going to be the most common data structure you're going to use. They're very handy, and they're simple. Simple does not mean trivial. That doesn't mean boring. It means, you know, we have a really good idea what they are. It's this linear collection of things that has a beginning, it has an end, and I can just, if I have like a list of numbers, and I say, like in that example, 5, 7, 9, 10, that's the list of the integers 5, 7, 9, 10. If I said 7, and I ask you, here's a test, what comes after 7? What's the answer? Come on. No, in the list. Let's try that again. Remember, it's not Friday today, it's Wednesday, so you should be all invigorated. So what comes after 7 in that list? 9. There you go. And it's a stupid question because you're like, well, yeah, it's what comes next. You know, it's a linear data structure. We've got an obvious forward and backwards. Sometimes we have nonlinear data structures, which we'll learn about later, not in this course. But this is a linear one. It's a nice linear one. And lists are fantastic. So let's just play around with lists a little bit. I know a lot of you have already, but let's just have a look. So if I take this code, you know what, I'm just going to make my own. A list equals, someone just start yelling out integers.
12.
7, 9, 32, 102, and one more. 68. Very specific. Print a list. 12, 7, 9, 32, 102, 68. Anything surprising at this point? Whenever I see something new, I'm always going to ask this. Get the type of it. Well, it's a list. It checks out. Now, an interesting question, though, is the list is like the outer thing here. And its type is list. A list is a variable that gets me to the list thing. But what are the types of things in that list? Integers. Yeah. I know a lot of times it seems like I'm asking trick questions because they're so simple. But remember, computer scientists are dumb. We've got to break everything down into the tiniest little steps. Well, if I add a dot here, there, it's a float now. But let's leave it as an integer. If you ever wanted to know, so like I can say, let's get something on one of these indices. Let's get index 1. And I will ask what the type of the thing at index 1 of that list. Now remember, here's the quiz. On the count of 3, I want you all to yell out, what should I expect to be printed out from line 3? I see a list at index 1. Hey. 1, 2, 3.
7.
Good. Not 12? No, why? Because that's 0. Right. Remember, because we're normal. Everyone else is weird. We like to take steps. We count the steps we take. So it says go to the beginning of the list and take 0 steps. That's the beginning. Take 1 step, and that's the next. That's why it's done that way. So there we go. Let's hit run. It's a 7, and its class is int. Cool. So yeah, a at 0, whatever. And we saw that string slicing thing that we did. Remember how I could say, give me all the characters from here to here? We could do the same thing with lists. Oops. So if I say list at index 1 to 4, and I don't really need this right now, we get 7, 9, 32. So we don't get 0, we get 1, 2, 3, but we exclude 4. It's always like include, exclude. Up to, start at 1 and go up to and excluding that number. And this is handy because we're always thinking, imagine this. Here's a fun little thing. So a list. How many things are in this list? 6. And let's prove that to ourselves. Print len of a list. 6. Looks good. But what's the last index in that list? 5. There is no such thing as index 6. Right? Because it's 0, 1, 2, 3, 4, 5. I have 6 fingers, hold up. So, if you think about it, I could do something like this now and say, well, start at 1 and go to the length of a list. And this would say, because remember, it says go up to and excluding this value. But what's the length of a list? It's 6, but there is no index 6. So this is fine because it goes up to but excludes the 6. So this is another handy little feature. If you're scratching your head as to, wait, why do I care about this? It'll become clearer as you get a little bit more practice. We always do the up to and excluding. That's always why I wrote those loops where I would say counter is less than something, not the less than or equal to, you know? Because we start at 0. Same idea. All right. I will also make a comment on, although we can do the slicing, which is awesome, and I do use it often myself when I'm doing something. But a lot of, like this strings, or this slicing feature, where we can use the colon to access fancy ways from, like, stuff in a fancy way from our lists. I personally, and I know I talked about this yesterday, I think, I personally tried to avoid overly Python-y things, where that is an overly Python-y thing. And the reason I do that is because if I want to like copy and paste my code from one language to another, a lot of the other languages won't have this feature. So I'm going to have to like really rework my algorithms if I can't use that. And I'm too lazy. So I'll write it kind of like the long way. That way if I copy and paste, my algorithms are basically the same. So I do try to avoid these things personally. But by all means, go ahead. Yeah?
Why do you switch programming languages?
There could be a variety of reasons. This is a very interesting question that we could get into, but I'll give you the short answer right now. Different programming languages have different features and benefits and whatnot. Every programming language, now there are a lot out there, but there are a small handful of popular ones that people actually use. There are some like joke ones people make. There's one called like whitespace, where it's just based on the number of spaces you write. That's like an instruction. Don't use it. But there are a bunch of programming languages out there. All of the popular ones kind of have their own thing. So Python is a scripting language. It was kind of designed with something in mind, and it's really good at what it was designed for. Java is another really popular one that was designed with a couple of ideas in mind, and it's really good at that. C it's an old language. C is a great language. It's an old language though, so some of the stuff that was put into C was like mind-blowing at the time, but C was very innovative. And then C++ was basically people stapling ideas onto C over and over and over again. But that's what it is. But C++, I might use that today if I'm really looking to get some speed-ups in my code, because it's arguably a little faster. Although I will warn you, don't trust all those benchmarking websites. Has anyone been interested? Like, has anyone who has coded before looked up, like, oh, which programming language is faster? And you can find, like, the benchmarking websites that talk about the speeds of different algorithms on different programming languages? Half a person?
But I didn't really look at
Cool.
I kind of, okay, what's
I gotcha.
this comes up?
So, a lot of people will cheat, and they'll, like, do things to make one language look better than the other, but it's not quite like that. But it's a much more sophisticated conversation that we could have, but we'll have that conversation later. Interesting question, though. The most popular languages these days, you're going to see Java, Python, C++, C, and C#, JavaScript. Those are probably the most popular ones. You can find lists online that tell you what the most popular ones are currently this year. Anyways, so I'll just do this activity. Actually, no, I'll give you a minute to try this. If you've got Colab open, just play around with these things. Like, hack around and see if you can find the answer to some of these questions. And of course, ask some of these other questions to yourself and see if you can answer it. Remember, the best way to learn this stuff is to just do it. Ask a question and try to answer it. So I'll give you only a couple of minutes to work on this one, because it's not too bad. It's just playing around. And remember, if you get stuck, feel free to work together. Okay, so I played around with the first one, and I put some floats in my list, and it worked just fine. Even more interesting, we can actually put a variety of different types in our lists. Here I've got an integer, a float, a string, another string, a Boolean, and another Boolean. And it's fine. It is happy with this. So I can have strings of all, or lists of all these different things, which is a little unusual for many programming languages. In many programming languages, we have a little bit more of a strict set of rules about what we can put in these like data structures in the lists, for example. Now, there totally are ways around it in other languages where you can have multiple types in there. But typically, if we're talking about something like an array, where an array is kind of like a list that we'll talk about next semester. If we have an array, typically you'd have an array of integers, and you can only really put integers in there. And then you might have an array of floating point numbers, and you can only have floating point numbers in there. So it's entirely interesting here in Python that we can kind of mix the types. So this is kind of cool. What type does the list have? Well, we already kind of did that. Did anyone figure out how to select the last 3 items? Raise your hand if you did. 1.5 people. Okay.
Probably not the easiest way, but I did it.
Okay, let's see. Now, let's assume we have an arbitrary length list. A list. Oops. Now, I could hard code the like, okay, well, 0, 1, 2, 3, 4, 5. So I want 4, 5, and 6. And we saw the slicing, so I can do something like this. Oops. Forgot my parenthesis. There we go. Oh, I guess 0, 1, 2, 3. I guess it's 3. There we go. I got the last 3 things. But we got a big problem here. Any idea what my problem here is?
It assumes any longer or shorter than that, it won't work.
Exactly. The list, but yeah. I mixed them up already today like 4 times. So if this is any longer, like this will only work for a list of length 6. Or 1, 2, 3, 4, 5. Yeah. So, I mean, I could do something like the length of a list, which would be 6, but then I want 3 before it. So I can do that minus 3 to the end. So how long is it? Minus 3, and then from there to the end. Not too complicated, but who still feels like, ugh, I don't know, that's terrible. Yeah, it's not pretty, at least. Totally workable. There's nothing wrong with it. The math checks out. And this will work for an arbitrarily long list. It'll get me the last 3. But it's kind of clunky. In Python, there's another way. You can actually just say this. -3. This is another really interesting, cool feature of Python that a lot of other programming languages don't have. You can't use negative indices. If you do use negative indices, it goes backwards, like it counts from the end. So this says from -3, so the third last one, to the end. But again, this is string slicing stuff. Or list slicing. I'm more just showing you this as like, oh, neat trivia. Not on the midterm type thing. And did anyone answer this one? Can you have a list with nothing in it? Yeah, of course you can. Remember, same thing with like an empty string. We can have a string, but there's nothing in it. You want an empty list? There. Print empty list, and then print the len of list. There. We printed it out, and the length is 0. But it's still a list. Let's prove that. There. There's the empty list. Its length is 0, but it's a list. So yeah, we can do that. Did anyone else kind of like ask their own question and try to answer it about something they could or could not do with a list?
I was kind of curious to see if you
Could you?
You can.
Yes, you can.
I did a bunch of them. String, in, float, Google, none, list, name function.
Perfect. Do you think you could have a list with lists in it? What about a list with lists of lists in it? Probably. Remember what I kept saying about programming? Is the computer scientists are too stupid to do anything big. We always have to break things down into these simple little rules and steps. But as long as we're following those simple little rules and steps, we're good to go. So if we can have a list where we can put like anything in it, can we put a list in a list? Yeah. Well, if you can do that, can you put a list in a list in a list? Yeah. Could you put a list in 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 a list? Sure. I don't know why you would right now, but you totally could. So a list is a data structure. The name is fairly straightforward. It's a structure that holds on to information, and it has some properties about how the data is stored. A list is linear. A list is, you can start at the beginning, go to the end. You can index it. That's the data structure. We can interface with it that way. Just because it's simple, however, does not mean it's not powerful. It's probably going to be the most used data structure you'll ever use. I know I asked this last time. Who here is registered for 162? Really high, really high. All right, hopefully by the end of the semester I can convince more of you, because it's way better than this class. It's way more interesting. Not to say this one isn't interesting, of course. It's just more. There, that's a good answer, I think. It is more fun. And I'm not joking. It is way better. You actually, you solve more interesting problems. That, again, not to say this isn't cool, but, the further we go, the more fun we can have. All right, figure out how to find the number of elements in a list. Well, we already did that. Write a function called print. You know what? We'll do this one together. Print list. I'm going to make a function called print list. A list. So, if I want to print out a list of an arbitrary length, what might I need to make use of here? What interesting Python statement tool do we have in our pocket, our tool belt, that we can use to give us a hand here? Remember, it's not a trick question. The answer probably is as simple as you think. Do we need an if statement? No. Well, what should I use? I see a lot of people they're answering no as if you know the answer. Just yell out what you think. You weren't paying attention. All right, I'll ask again. I have a list of arbitrary length. Maybe it's length 5, maybe it's 105. I want to print out all the contents of that list. And I'm writing a function to do this. What programming tool in our tool belt do we know of that might be really handy here? A for statement, a for loop, of course. A loop. I guess it doesn't need to be a for loop. It could just be it could be a while loop. But we're going to definitely want to continue doing something until we run out of things in the list. To me, the easiest one I can think of is a for loop. For thing in a list, print thing. Okay, good. There it is. And then print list, and we'll give it a list. Actually, I'll give it another list. There we go. Looks good to me. Another list was the one that had all those things. Now, you can't really tell the difference between what's a string and what's an integer here. But an interesting fact, and this isn't something you need to memorize right now, but an interesting fact is whenever you do print, Python, the print function actually turns everything to a string. So that true, that false, all those things there are actually technically strings, but when they're printed out, they're not like in the program anymore. Because they're still left as their regular type in the list. It's just when they get printed out, they all get converted to strings before they get printed out. FYI. Now here it was with the... Pardon? Yeah, it doesn't change anything. All it does is has this side effect of showing you something. That's all. And then let me prove it to you. Type of another list at index -1, the last one. No. Yes, I did. There, it's still a Boolean. The last thing's a Boolean. It was false. So they're still left unchanged there. So we did it with a for loop. You know what? For fun, let's just do it with a while loop. Just because I always like to practice. Counter 0 while counter is less than the length of a list. This will tell me however long any arbitrary list is. We'll print out a list at index counter. And am I done? Does this look good? Seeing people nod no. What am I missing? I'm not incrementing counter. If I run this, what would I expect to see? It's going to run forever and it's going to print out 55 forever. Because it's print out index 0. Is 0 less than the length of the list? Yeah. Print out index 0. Is 0 less than the length of the list? Right. So we got to be sure to say counter plus, pardon me, plus equals 1. Let's run it again. There we go. We're good. I will take, no, I'm going to show you something neat later. So write a function, even print, that takes a list and argument and prints out only the even elements in the list. Okay. Write a single line Python code to test. Well, we'll skip these, but these are maybe good practice for you later. So a couple of list things we can do. This is going to be analogous to the string trivia I showed you last time. If you don't memorize it from today, that's fine, but note that there are a bunch of interesting things we can do. Remember how we could concatenate strings, right? If I have a string and another string, and if you add them together, they go like this. Want to bet if you can do that with lists? Raise your hand if you think you can. Raise your hand if you think you can't. Oh, you're going the other way. Well, let's have a look. It's just you're used to me throwing in trick questions every once in a while. Well, let's see what happens. Print a list, no, here, equals a list plus another list. A list was the first one. Another list is this one. And then print. It worked. Going against the grain didn't work out this time. That's okay. So this works. You can concatenate lists. Remember how you can multiply strings to get it to like repeat itself a number of times? Well, we'll just have to trust that there's 55 of them in here, because I'm not going to count.
I'm pretty confident there is.
You're pretty confident there is? I hope so. So yeah, we can multiply lists to make it repeat multiple times. That's pretty cool. Okay, range. Now, I will say that, I think I talked about this in lab, if you were in one of my lab sections. Now, in Python 2, range, the range function actually gives you back a list. So if you say range 10, it'll give you the list of 0 through 9. If you say range 5 to 20, it gives you a list of the numbers 5 to 19. It does. In Python 2. In Python 3, they made a tiny little change where if and I can prove, there is a way to open a runtime in Python 2 in the Colab, but I don't know offhand. But if I say a equals range 10, if this was Python 2 and I were to print out a and then print out type of a, it would say list, and it would be a list. Where now it's this like funny range object thing. But don't worry, there's an easy way around it. You just say, okay, but be a list. There. So you can just do this as a really quick and easy way. If you need a list of contiguous numbers, range is really handy. It's fantastic. But range is also, as we saw before, really handy in for loops as well. If you have a for loop, because remember with the while loops, we had that counter that kept counting. But we can use a for loop to kind of do that for us pretty easy. Like, if we go up here, I'm going to go here and replace this while loop with a for loop, but I'm going to use the for loop entirely differently. Instead of saying for each thing in the list, I'm going to say for each index that there exists for that thing. I'll show you what I mean. It's probably easier to just show you than explain with English. So I can say for I in range, the length of a list. So what this is going to say is first, okay, what's the length of the list? I don't know, it was 6 or something. Then it's going to say for range to 6. So that's kind of like giving me back a list of 0 through 5. And then I can use 0 through 5, that variable I, which the first time through the loop is 0, then 1, then 2, then 3, then 4, then 5. I can use that to index my list. So print a list at index I. And then here, and it works. Now I don't need a counter variable because it's kind of like baked in to the for loop. So I'm now going to try to confuse you, but trust me when I say I'm not breaking any rules. All the rules you've been taught so far apply the same, even though what I'm about to show you might throw you off a little bit. So if I'm just going to go down here to a new block. Okay, so if I have a so I have a new list. It's the list of the numbers 0 through 9. Okay? This is the same as me doing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So there, I've got it. What am I missing? I've got an extra bracket. So great, I've got this list. So now, if I say for I in range, len, okay, no, I'm going to do it this way first. You know what? I'm going to turn these into letters. Because otherwise the indices and the values in the list can get confusing. So let's make these letters. No. C, D, E, F, G, H, I, J. Okay, so if I print it out, I'm going to print out I followed by a new list at index I. Okay, so 0A, 1B, 2C, and so on. Okay, I'm printing out I followed by what's in the list at that index. Questions about this? Now pay attention because this might annoy you, but it's an important concept I want you to keep track of because the concept we're about to talk about is really going to matter for the concept we're going to talk about next. I'm going to get rid of this. And what I'm going to do is say, okay, I'm going to say a new list at index I equals X. And then print a new list. Okay. Take a second, look at this code, and come to the conclusion of what you expect to see happen after I run it. So Raise your hand if, yeah, you know what's going to happen. Only a couple people? Uh-oh. Let's try that again, because at this stage, you should totally know exactly what's going to happen. So, when I run this code, I've got a list of the letters A through J. I'm saying for each I in the range of the length of the list, so for each index that corresponds to, okay, 0 is A, 1 is B, and so on, I'm going to say A list at location I and replace it with X. So when I hit print, what do you expect to see? Raise your hand if you know what you should expect to see. Okay, it's a little better, but a little concerning. Is this what you expected? Good, good. You should expect this. At this stage, this should be easy peasy. Now, here's where things might seem weird, but trust me, it all checks out. Before I show you this, I. The first time through the loop, what value does I get assigned? Then what? Then what? Then what? Exactly. So I'm going to change this now to, I'm just going to comment this out. And I'm going to like the other way of the for loop, where I could just say print thing. And I hit run, I see A, B, C, D, F, G. Because each time through the loop, thing is what? Exactly. So it starts at A, then becomes B, then C, then D. So here, I'm going to change this to be like this. So instead of saying A new list at index I, we don't have an index I anymore. I got rid of it. I'm going to show you this. Thing equals X. So now when I hit run, what do you expect to see? Take a second, think about it, and come up with an answer, and then we're going to do a poll. Raise your hand if you have an idea in your head. Really high, I want to see. All right, let's see what happens. Were you right or wrong? Raise your hand if you were wrong. Most of you are probably wrong, and if you're saying you're right, you might be lying. Here's why. Thing is not. Thing is a variable that the first time through the loop becomes A. When I said thing becomes X, all I did was modify thing. The variable thing became X. But the actual element in the list was left alone. And I'm going to draw it just to make sure I get the idea across. So I had a list that was A, B, C, D, E, F, and so on. At the back, can you see that reasonably okay? All right, cool. The first time through the loop, thing, no, is a variable where I copy over the contents. A, okay, thing is A. Great. Then right below I say, no, thing, you're X. Oh, okay, all right, thing, you're X now. Great. But the list is left alone. Nothing changed in that list. If we go back to the way it was before, is there an eraser? Yes. Where I was doing it with the I, there. When we do it this way, it actually does change it all to X's. Well, here's why. Because what's happening? Well, I have I. And then I say a new list at index I. Oh, okay, well that's this. This becomes what? Oh, X. Then the next time through the loop, I. Well, I is 1. What is a new list at index 1? Well, that's this right here. We didn't make a new variable to copy over the contents that we then modified. We actually went to that list, indexed it, and then modified that list. This right here is really emphasizing that idea I was talking about before, where classically speaking, we have like the primitive types, and then we have objects, which are different. where an object, we don't know how nicely it fits. So when we have variables to objects, the variable doesn't hold the object. The variable holds information that tells us how to get to that object. So we can skip this. Mutability. Well, I already kind of answered this. Remember, what was the fancy word we used to talk about strings? What are strings? Immutable. What does that mean? You can't change it. Once the string exists, that string cannot be changed. We can make a new string based on that string and make modifications before we save it as a string, but that actual string cannot change. It's immutable. Lists, on the other hand, are changeable. They're mutable. And if you don't trust me, well, we just did that. I just changed the contents of a new list at index I. We can actually change those things after the list is created. You might be wondering, well, why on earth could I do it here, but not with strings? And that's going to come down to what's actually stored in the list versus what was stored in the string. But this is an idea we'll talk about a little bit later. So what do I have? Okay, these are boring activities. Okay, so I'll show you an example of something else interesting. 5b equals 6, print a, b. Then I say a equals b. Okay, look at this code, and in your head, come up with the answer you would expect to see printed out. There's no, I promise you, there's no trick to this. It's just, it's this simple 6 lines of code. 7 if you count the blank line. Is that what you expected? I hope to God it is. Great. Why? Well, okay, we made A is 5, B is 6. And then I say, print them out. Okay, 5, 6, great. Then A is equal to B. Okay, we'll take the contents of B, which is 6, and move it over to A. So A is now 6. And then I say A equals A plus 1. Okay, A is now 7. So A is 7, B is 6. Great. Any questions about this? Good. I'm going to basically do the same thing, but down here with lists. So I'm going to say A equals 5, B equals 6, 7, 8, 9, 10. Print A, B. Let's just print this out. Are we happy so far? Yeah? A is this, B is this, print them both out. All right, 1, 2, 3, 4, 5, and then another list, 5, 6, 7, 8, or pardon me, 6, 7, 8, 9, 10. Cool. So now I'm going to say A equals B, and then like on line 6 here where I modified A, I'm going to modify A. I'm going to say A at index 0 is equal to WTF, okay? And then I'm going to do this, and I'm going to hit run. Think about what you expect to see here. This isn't a trick question, but it's totally going to feel like one. All right, raise your hand if you have your answer in your head. Even if you're not confident with your answer, just let me know if you have an idea in your head about what you should expect to see. All right. Were you right or wrong? Raise your hand if you were wrong. Raise your hand if you were right. You were right. Interesting. Interesting. So what the heck happened here? Let's follow this code. Okay, A equals 1, 2, 3, 4, 5, B is 6, 7, 8, 9, 10, print them out. Okay, the first part's fine. Then A is B, so we copy over the contents of B to A. Then we modify A. We're saying, okay, A at index 0, B WTF. So at index 5, A became the list 6, 7, 8, 9, 10, right? Because I said B equals A. And then I said A at index 0 is WTF, then I printed them both out, but I've got the WTF in A, but I also have the WTF in B. But I never changed B. It honestly, like right now, it looks like I did this. B at 0 also equals WTF. In fact, let's see what happens if I do this to WTF. And I'm going to hit run. What the heck is going on here? So raise your hand if you're looking at this and you're saying WTF. Yeah. So, there actually is no trick to this. But I was using very imprecise words before. So, before when I said on line 5, A equals B, copy over the contents of B and put it into A. That statement is correct, but I said A is now that same list. Which is not quite correct. Just one sec. What A and B really are the information we need to get to that list. So, imagine this is a list. And let's say I have like A equals, and this is like the box that represents the variable for A. And I say A equals that list. Well, in reality, that list gets put somewhere in RAM. But in the variable A, what I have is the information that gets me to the beginning of that list. This, depending on the programming language you're using, this is sometimes called a reference, sometimes called a pointer. But the idea is, it's the actual information we need to get us to where the thing is. When I copy over B, let's say I wrote B equals A. B equals A results in this, copying over the contents of A. The contents of A, not the list. The contents of A is this arrow that gets us to the list. So I copy over that arrow. At this point, I now have two variables that get me to the exact same thing. And this is called aliasing. And we're going to talk more about this Friday. Today's Wednesday. Yeah, Friday. Sorry, I missed your question. What was it, real quick?
I'm just going to ask, so if you say A equals B, does it also work in reverse?
Yeah, it will. Because it's just, like if I, let's see. There. It's just the difference now is we're dealing with this one because it's what one it referenced. Cool.